Hey guys, welcome to my YouTube channel where we learn how to program and how to make games from scratch. Today's topic is linked lists. How do they work and what are they? Well, stay tuned to find out more. So by the end of this video, you will have a better understanding of what a linked list is, what it is comprised of, and the different functionalities it contains. So don't forget to subscribe and hit the bell icon to get notifications when a new video gets uploaded.
A linked list is a sequence of elements, usually known as nodes, where one node is linked to the next node. These nodes contain the following variables: the data and the pointer or link to the next node. So, how do we know when we have reached the end of the node? Well, this is simple. In this particular list, you know you have reached the end of the list when the next pointer or the link is empty or null. What type of data can you store within the nodes? The type of data that you can store within these nodes is pretty much up to you. They can range from simple integers to strings, or even more complex things such as objects or classes. The data stored within these linked lists can be sorted or unsorted. It all depends on your needs, and it can contain duplicate, or if you wanted to, it could only contain unique data. So then what are the differences between arrays and linked lists? Some people may glance at these structures and think that they are the same, but in reality they're not. The memory or data within the array is contiguous. This means that each element borders the other elements within the array. This makes it very fast and simple when accessing the data. This is due to the fact that when using an array, you need to specify its size prior to being used at compile time. Linked lists, on the other hand, are not contiguous in memory. Each memory space is created only when you add a new item into the list, making it fragmented. Because of this, and thanks to the next pointer, we can only go in one direction in this type of list. Because the memory is not contiguous, we cannot go backwards. On the upside, a linked list does not require you to predefine its size during compile time. It will grow as big as your system memory will allow it to during runtime. Other linked lists to note are doubly linked lists, where the only addition to it is the previous pointer, allowing you to go backwards. This, keep in mind, will also increase the memory that you have to allocate for the whole list. The last one is called the circular list, or circular buffer. This particular linked list does not have an end. It just loops from the last node to the start of the list. All linked lists, however, contain a set of basic functionality to do the following: adding a node to the list, removing a node from the list, displaying the contents of the list, and I guess also fetching a node or data from the list. They also contain at a minimum of one point of reference to let us know where the start of the list is. This is called the head node. Some additional references that are not required but may prove to be useful are the tailed node. This node lets you access the last node from the list. And the middle node. This is located at the center of the list, but it is rarely used. at least in my experience.
Hey guys, if this video is making sense, please comment down below. Let me know what you think so far of this video, and if you're having issues or trouble, please post them on the comments below. Thank you.
Okay guys, so now we're going to start with the implementation for C++. This part is just setting up the main function so that the program can start and finish properly. And the first thing that we're going to start with when creating the list is the node. This is a little recap for you guys to remember what goes inside of a node. The data, which in this case we named it value, and is an integer, and the next pointer, which is of type node. We're going to make sure that these are public so that we can access them outside of this class. Now you can make them private and then have getters and setters. This is the constructor, and what we are doing is we're just creating a constructor that can pass in a value. We set that value to the node's value, and then we just make sure that the next pointer is always 0 or null, which is the same thing, so that we don't get weird issues if there is an error. You always want to make sure to initialize your variables somewhere before using it. Alright, so I'm including IOStream or IOStream header so that we can use printf, and this print function is going to work. How this is going to work is we're just going to print out the value that each node has. This will come in handy whenever we are printing the whole list. Alright, so that's pretty much it. Now we're going to create another file. This one is going to be the list, and we are going to include the node so that we can use it. And so here's another little recap of what reference points we are going to be using. For this one, we're only going to be using head, and the reason why it's private is because we don't want to use it anywhere outside of this class. So we're going to be adding, removing, and printing in this thing. So first, before we do anything, we want to check if the head pointer has any data. The way we check if it has any data is if it is 0 or null. If it's 0 or null, then we're going to create a new node within that reference point, which is the head, so that otherwise we wouldn't have anything in the list. This else statement handles what if it does have already, several pieces of data. Well, in that case, we have to iterate through each node that we have until we reach the end of the list. And the way we know that we are at the end of the list is how we said earlier, that the next pointer for that node has to be null. If it is null, then we are at the end. And once at the end, we can add the new node, which is just that simple. And we don't have to do anything within that for loop. Now to print, we only really care about if we do have any data. So if the head is not null. If we do have data, then we're gonna go through again the whole list, and we're gonna print out debug stuff to show us all of the data pretty much. If the head is null, that means it's empty. So we're just gonna print that it is empty. Here we're using the print function that we created for the node. And we're just displaying the indices of each node by having an integer called count, and we increment it every time we go through the loop. And that is pretty much it. Oh no, wait, we're gonna remove now stuff. All right, so removing works pretty much the same as adding, but we only really care if we have something inside of this, just like the print function, because we can't remove something when there's nothing there. So what we have to do is we have to check the value to see if it's equal the value that's coming in that we want to remove. If it does, here we actually need to have another reference point, which is the previous pointer here that we're going to keep track of. So whenever we loop through the list, we're going to have two references: the current, which is the iter, and the previous, which is the previous. If the previous is not null when we get out of it, that means that we need to make sure that the links between the whole data doesn't get messed up. So yeah, we just pretty much, we are gonna delete iter, so we need to go and link up the previous next pointer to the next pointer of the current one that we're gonna delete. It's a little bit confusing, but I hope it makes sense. And yeah, if the previous pointer was null, that means we only had one thing to delete, which was the head. And here we're just adding adding data to the list so that we can test it out and see if it works properly. So yeah. Then we pause the program so that we can actually look at it, and we run. And as you can see, we are adding values correctly, and we're also removing values correctly. Okay. All right, so the next thing that we're gonna do is the C# implementation, which is the same as the C++ implementation. The only differences are some structural things, like if you want a variable to be public or private, each variable has to have that, and each what's it called? Each function also has to have public or private. And instead of a arrow for pointers, you only have dots, pretty much. But it works the same way. Alright, so that's the node. Now we're going to create the list. Now, in the C++ implementation, usually you have a CPP file and an H file. The H file contains the kind of like the prototype, I guess you can call it, of the class, and then all of the functionality goes into the CPP file. The reason why I only created a header file was because it was simpler. Neither way is wrong or right, but I guess it's up to you what you like. In C#, you only have a CS file. There's no header, there's no CPP. There's only one file for each class. So that is, I guess, a plus. I don't know. So guys, if you like this video, If you like this format, let me know in the comments below. If you like what I'm doing here, showing how to create the same thing within different languages, let me know as well. If you prefer a language, also let me know. If you do prefer one over the other, so that maybe we can focus on a language that you all may want or like. Another thing is, if you like what I do, I'm all about helping people, teaching people, because when I went through, this myself, I went through it pretty much alone, and it was tough. So I'm trying to, I guess, help you guys out as much as I can. If you do like this, and if you want to support what I do, please don't hesitate to go to patreon.com/Wulfers. It will be very much appreciated, and it'll help me make more content and get better at making better content for you guys. If you have any idea on what you want to see next, post it on the comments below as well. Anything helps. I can only help you guys if you guys help me. I don't know if that makes sense, but okay, so now we're pretty much towards the end. We are going to be creating a list here and just adding, removing, printing, and pretty much running the program like we did with C++.
Well, there you guys have it. This is how a singly linked list works. If you guys like this video, please hit that like button. This will allow more people to be able to find my videos. If you have not already, please subscribe and hit that bell icon so that you can get notifications for new content. And if you guys think someone else could benefit from this video, don't hesitate to share it with them. And please let me know what you guys think of this video in the comments below. Your opinion matters to me, and it will help me produce better content for you. Or if you just want to say hi, drop a comment down below. Thank you guys for watching, and I hope you guys enjoyed it. Have a great day, and see you next time.